uh,
Okay.
where a long time ago, but I think in terms of research and how that has impacted my association with the division, the environmental division, and other divisions, is really tied to different parts of my research over the years. One is in terms of basically the.
So welcome to the interview sessions that we are conducting as part of the 50 years of AIChE Environmental Division. My name is Debalina Sengupta. I'm the Associate Director for the TEAS Gas and Fuels Research Center at Texas A&M University. And I'm also the past chair for the Environmental Division. It is my pleasure to welcome Dr. Yoram Cohen from University of California, Los Angeles. And I would like to start with Professor Cohen giving us an introduction of himself.
Thank you for doing this series of interviews, and I think it's important for the division. In terms of introducing myself, I've been with the division for many years, since the late 70s, I believe. And my involvement with the division started because of my interest in the area of contaminant transport in the environment, and basically introducing the whole concept of multimedia environmental impact assessment, trying to understand where do chemicals go when they're released to the environment, what is their impact on various ecological receptors, what are the risks that are imposed, and really go all the way to the area of risk assessment. But in the process, really focus on the fundamentals of what is fundamentals in chemical engineering, which is transport, be it transport in the atmosphere, transport in soils, in water bodies, transport to groundwater, and then, of course, trying to understand that from a modeling viewpoint, from a mechanistic viewpoint, and to put it together into tools that can be used to actually do impact assessment. So that was the start. And then when I got started in this area, people, when I would say that I'm working in the area of multimedia assessment, they said, "You mean radio and TV?" I said, "No, that means air, water, soil, and so on." So eventually, we started out with a Center for the National Center for Intermediate Transport Research, which was one of the first centers of excellence by the US EPA. And that really allowed me as a member of the center and then its director to push this whole area of multimedia impact assessment. And this was really my foray and entry into the environmental division at that time. Eventually, multimedia assessment actually became part of the Clean Air Act, and in fact, in every environmental assessment that is done today. So moving forward, I also, over the last maybe 10 years, more like 12 years, have been involved in work on nanomaterials and the impact of nanotechnology from an environmental viewpoint, and that was through a National Science Foundation Center, which I was the co-PI. And that also, of course, very much connected to the environmental division, as the whole area of nanotechnology has sort of swept, the nation and the scientific and engineering communities. And throughout this time, I've also dealt with, and I'll make the connection, I dealt with membranes, and particularly looking at the issue of water technology, so water purification, water treatment, water desalination. And this is where the connection, came in also with the environmental division. And so I think that I was probably one of the first to at AIChE to introduce in an organized way the whole approach to water technology and programming, and not only at the environmental division through various specialty conferences that we held at the AIChE, but also later as I became also the division, chair of the separation division. So prior to that, I was division chair of the environmental division, and so having knowledge of both was really a great opportunity to to build ties and to build connections between the two division, which today is very, very strong with the environmental division and many other divisions. But that was really at the very, very beginning. So when I got really involved with the environmental division almost disappeared from the. When I entered, it was a situation where it almost disappeared from the annual meeting. I think that there were maybe a handful of session, if that, and there were even talks at that time to completely cease programming at at the annual meeting. And I think through the effort of many of the pioneers of the environmental division, it was the realization that this was a division that can in fact be the glue that will tie together and be applicable to multiple other divisions in other areas. And in fact, that's what has happened over the years. And so it's very gratifying to see that, where from being sort of a small division that is, I don't want to use the term fringe, fringe division, but it actually grew to be, a force to reckon with within, the AIChE. And I think basically in the profession overall, in engineering, not just chemical engineering, but in all other aspects.
I would definitely echo your thoughts on that because, of course, as we see with many things environmental, not only with the AIChE, but with any companies or any other entities, right. The EHS group, the Environmental Health and Safety Group, is kind of somewhere considered to be something additional or not the core business. And that mindset has probably changed over the years, thanks to the work done by stalwarts like yourself and bringing in the value for the environment and its different stressors that has impacted the environment. So going back to your original concept, you said that you started in the 1970s, so it's almost as old. Your research portfolio is almost as old as the environmental movement itself. So can you tell a little bit about the start, how it all started, how you conceptualized it? Because those are the things that us who are getting started in research would be looking forward to for the next 50 years or so.
Well, sometimes in life, I always say that life is a collection of unintended consequences, and that is the case with me. Very, very briefly, I did my undergraduate and master's thesis at the University of Toronto in Canada. So at that time, I got involved with two issues. One is the contribution of the atmosphere to the chemistry of the Great Lakes, and the other was dealing with issues that had to do with oil spills on Arctic terrain. And you might say, that's an esoteric topic. Why? Well, because at that time there were talks about building a pipeline that will go from Prudhoe Bay across Canada to the U.S. And of course, it would go through the tundra, through Arctic terrain. and there were fears about what will happen if there are oil spills and so on and so forth. To make a long story short, that was the beginning. And in fact, I think I presented one of my first research papers back in, I forget, 72 or 73, which was just 3 years after the formation of the US EPA. So, and that was actually in Washington, D.C. And that was really the very, very beginning. As I went on in my career, I sort of switched, and my PhD was in the area of polymer engineering and non-Newtonian fluid mechanics. Very different, but I did a side, gig in sort of doing a minor in certain aspect of oceanography and focusing on wind wave theories. And numerical analysis. And then what happened is that as I got to UCLA, which would again, I won't get into the story of how I ended up there, but it was right at the beginning where there were plans to form an environmental center. And at that point, my career was going to be mostly in the polymer area. But this was a side thing, and we were successful. And the first center, environmental center, was born, one of 8 at the time. And I got involved with the US EPA, with the with the EPA Science Advisory Board. Later on, with the National Research Council Board of Environmental Studies, on which I served, on the President's Environmental Council. And sort of learned more and more about not just the scientific part of the environment, and this is important to emphasize, but to understand what are, the regulatory implications, the policy implications. I'm not a policy person, not a regulator, but I've learned that if scientists want to make a difference, they better understand the regulatory implications of what they do, how science can make a difference, and what it is that they can push and explain, and not to be afraid to interact with, in my case, interact with toxicologists. I've done work on developing toxicity models, and I'm not a biologist, but it was all with the eyes of knowing what's important from beginning to end, and working with people that have expertise in biology and in policy, and realizing that this is a team effort when you deal with environmental issues. And if you do, then you can make a difference. And so I think over the years, you mentioned about environment being a side thing. You can even see it in the terminology and how we named, the environmental efforts. The first center that we had at UCLA, an NSF center, was a Center for Hazardous Waste Minimization. The second, after that, we talked about pollution prevention. Then we talked about green chemistry. Then we talk about sustainability. So you can see, even in the names, as we progress forward, we went from accepting that there is a waste and you just need to minimize it, to then prevent, prevent pollutions, emission discharges, to green, sort of engineering, green chemistry, to sustainability. So it's a whole change in a mindset, and in the profession that I've seen over my lifetime, my academic career, that has taken shape to the point where the environment and environmental issues are no longer sort of a side issue. In many cases, they become the core issue. And that is true in what I also do today in the water area, which is to develop new water, new and safe water, sources, whether it's for disadvantaged communities, for example, where we're putting our science to actually solve real world problems and to provide people that otherwise would not have access to clean water at all, have access for the first time. And I know that there are other colleagues of mine within the environmental division and also the separation division at AIChE that are doing that. But I see a whole progression where at the early years, if you did work in the environmental area, it was sort of, okay, you're doing work in the environmental area. It's not so, what's the glory in it, right? And I think that now it's very, very, very different because it's a core area, that has gained a lot of respect.
Absolutely. And that is what we have also, like I'm very new, about 10 years in research. But what we have seen, and I started with sustainability research related to environmental problems. However, like as you mentioned, we have seen this change from pollution prevention to sustainability to now more comprehensive and more inclusive areas of work. And in some sense, environmental research is a convergence research area where many different fields have to work together to bring science into action.
Right.
So in that respect, you mentioned your work on transport phenomena of the fate and transport of toxic pollutants, and you also mentioned water, like creating new water. Can you give some examples of projects that you have done that has been very close to your heart? Some things that you have felt has been most fulfilling for yourself.
So I can tell you that from my perspective, of course, as a researcher, as a scientist, as an engineering scientist, we take pride in fundamental work that we do. Okay, so if we develop a new multi-phase model for transporting soil, if we develop a new model for rain scavenging of pollutants from the atmosphere, if we develop new theories for air-water exchange of contaminants and the impact of waves and various aspects of wave theory and how that affects it. So I can go on and on, but you get my point here, that we can do very fundamental work in different areas. We can also develop models that look at the environments from a multimedia perspective of how all the compartments, environmental media interact. But at the end of the day, and I guess I can say it today after being around for many years. I said at the end of the day, when you look at what you've done, it's not the number of papers that you've published. It's not the number of papers that have a citation number above a certain value. But to me, it's whether or not the work that I have done and the science that I have done was put into good use, and whether or not it has made a difference. And so here is where I can give you a number of simple, examples. Not to tell you about paper X that was cited so many times, or this award that one received. But to me, it's where my research, for example, has been instrumental in helping the town of Valdez in Alaska to force the issue of putting vapor controls on oil tankers that basically cause pollution levels in the area of the oil loading terminal, which is one of the largest in the world, to raise the level of hydrocarbons, benzenes, and other chemicals in the area. So it's all through research that led into environmental impact assessment, but based on the models, on the theories that were developed over the years. And that was successful. Another one example is with regard to hazardous waste sites. And one of the large sites here or two sites here in California, the Stringfellow acid pits, they're all Superfund site. and also the Santa Susana Field Laboratory, which was a site for rocket testing, for many, many years, including where I think one of the first near nuclear meltdowns occurred in a research nuclear reactor. But there is also to make recommendation to the state of California and at the federal level about what are the issues that are facing the communities, and what is it that needs to be done, and all of that is based on very, very detailed scientific analysis. So it's not just because the models that we have, or the scientific approaches, where it's not that people just said, oh, let's use this model that Dr. Cohen developed. No, that's not the reason. It's because you work to develop trust, and you do it because people will trust that you will work in a comprehensive way with different people, put teams together, and do analysis that is meaningful, and make recommendations that will be beneficial. And I won't get into the details of what that amounted to, but in our case, for example, it led to a California law, okay, that was enacted in order to force cleanup in certain areas. Nowadays, one of the projects that I'm devoted to is that we've actually used technology that we developed, over the years, and did a lot of fundamental works, but in fact put together membrane-based system in remote communities in the agricultural areas of disadvantaged communities, to purify their groundwater, which is their only source for drinking water. So with actual systems that have permits. So and developing the whole concept of virtual water district for people that don't have access to centralized systems. So to me, in terms of gratification for what I've done and what the work is beneficial to, this is one example. I mean, those are a few examples, and others, of course, are not linked to the environmental area, directly. Is in terms of developing new membranes, working with industry to implement those, and showing the way in new and emerging areas, such as in the nanotechnology area, as to how we can predict or forecast potential toxicity, or what makes nanomaterials non-toxic, or what properties just as important. And that goes back to the issue of sustainability. How can we develop nanotechnology in a sustainable way? Okay. So I hope that those sort of examples, just few examples, give you a sense of where in my view it's the implications and the deployment of the science that at the end of the day are going to be important and critical. That's not to take away from anything else. It's not to take away from developing new approaches that encourages others to follow. I mean, obviously all of that is important, and everyone that does research hopes that that happens, that people will follow what they've done, that you'll tempt others to move forward. But in terms of what's close to my heart, it's helping society.
Yeah, that's a very good perspective, because all our science and research is to serve the communities where we work in. So you mentioned a very important point, and as you mentioned, that we come over the years with different perspectives of starting from thinking about waste as something that is probably generated, to being more definitive that it is generated and we have to deal with it from the beginning, instead of like trying to treat it as an end of pipe treatment. So what do you think going forward? You mentioned nanomaterials and nanotechnology, and the impacts of those are not as well defined. We have seen it with the microbeads in different products. We have seen it with the microplastics. They are also comparable to nano substances. So what do you think, looking forward, what are the environmental problems that we are facing that we have to solve? What is your perspective on that?
Oh my. Uh, it's one thing that I'm glad about what you said. You said what environmental problems we have to solve, because when I started, a lot of what we did was to identify problems, and the more environmental problems that you can identify, the more glory that you had. I think that nowadays I see more and more emphasis by many to actually propose solutions and implement solutions, which I think is the direction to go. Now, in terms of what are the major issues? Well, I'm not sure that I'm really the qualified person to make a very strong statement about what I think is most important, but I can tell you about a few that are all important. I think global climate change and loss of diversity are critical. I think that most I don't know if most people realize the rate at which we are losing habitat. It's alarming, and I don't mean just deforestation, but I mean loss of species and species diversity. And that's not just from pollution, it's from overutilization. So here we go into sustainability, right? Overutilization of resources that leads to a problem. So I think that in terms of, if you look at it in terms of a global problem that can have catastrophic impact, this is one. And I'm not going to get into what are the various factors that are included in here, because there are many, as I mentioned. It's still continued, pollution, discharges, overutilization of various materials, natural resources. All of that, causes problems. Some of them are on a more, local, regional. Some are more, global. I think that the issue of obviously I'm going to show my bias because I'm involved in the water area, and I see it today, is that we're losing water resources. Okay, we're losing water resources because of overutilization, in many areas because of seawater intrusion. We're losing water resources because of contamination associated with many factors. So not to point the fingers, but it could be agriculture. It could be, in some areas because of discharges. All those things have an impact. And so it also has to do with infrastructure. So while in the environmental area, if you deal with environmental ecology and environmental management, that's part of it. Okay, that's part of how do you maintain your your infrastructure so that you will have sustainable supply of water, that you'll have air that is breathable, that you'll have forests that will be sustainable, and that you'll have sustainable agriculture. So I think we have to look at it from that viewpoint and then ask ourselves, what are we doing that impacts all of those, and then what are the major problems that need to be solved, and really rank them in that level. Everybody, you mentioned nanotechnology and if that's important, and I would say yes, but I will be honest with you, is that with nanotechnology, what's important is that we don't make the mistake of the past, right? Where when we woke up years later to realize that we were dumping chemicals all over and didn't really know what their impact would be. So here we're being, careful, but I'm, I guess, a bit more, gratified that we do have environmental laws in place that are actually fairly protective, even of nanomaterials, because in many cases, the protection against the protection with respect to concentration of certain materials is lower than the concentration that would be imposed by the nanomaterials themselves. So a lot of the research that is done on the toxicity level is to see, is there something unique to nanomaterials that just because they're in the nanoform, they will cause more of an issue. And there are some examples, but so far, it's not at the alarming, level that people thought. On the other hand, I think that it's critical to be cognizant of it, that we don't simply put it aside and then realize one day that slowly production of certain nanomaterial has been ramping up and we were not prepared. So I think that efforts in there, will continue. It's sort of sad a bit that the Europeans are doing a lot more in the area of environmental protection with respect to nanotechnology than in the US. Or let's say that they're being more proactive.
Mm-hmm. Mm-hmm. So that is a very important concept that you bring in, that the Europeans are ahead in that sense. So do you think it's what do you think makes them more proactive? Is it the education? You have been an educator yourself. So how do you think we can bring the concepts of environmental protection, environmental laws, environmental values into our chemical engineering curriculum, if you share some of your experiences of bringing that?
Well, this all has to do with policy and politics, and the state in which our country is right now. It's a mess. So I'm not sure that that I have the answer, but it's a question of priorities. In the EU, there's the EU Union. People come together. I participate in a number of EU groups that, in fact, are doing research in the nano area. So I see what they're doing. Different countries are collaborating. They promote large-scale efforts that involve multiple universities, sort of similar to what we do in terms of research centers, but I think theirs are more mission-driven than ours. So I see as a result of that that the European Union has moved forward, but I also see that they move forward, especially in the nano area, because they don't see that same movement in the U.S. So the U.S. EPA is still, has been the gold standard for many countries. But since the U.S. EPA is not coming up with the kind of standards that, they think are needed, they're moving ahead. And that's what we see. And the same is true in other areas, as well. And, in the U.S., you have to remember that there is also tremendous difference from state to state. Here in California, there are, strict environmental regulations, probably, stricter than in most states. Okay, I'm not going to say across the board, but I know certainly that in the area of air pollution, even in the area of water. And so, if you're on the industry side, you might say it's more restrictive. If you're on the environmental protection side, you would say, terrific, that's great. We're being protective and proactive. But I think that at the end of the day, what's important is for scientists, engineers to get involved. To get in, and there are many ways to get involved. In terms of impacting policy, and you don't have to become a policy maker or a political scientist a policy, researcher. But you can get involved. You can get involved in various, committees that will have an influence, whether it's at the state level, whether it's at the federal level, and basically participate. And you'll be surprised. There is a real need, and when people show up, that have knowledge, they're tapped. But typically engineers, scientists, we tend to shy away from those things. We just want to do our technology, our research. We don't want to get involved in all this political brouhaha.
So do you think that bringing these concepts, again, I think the bringing this into education, into the university curriculum, how has that happened for yourself? How have you brought this into education?
So I can give you two examples. It so happened that this quarter I'm teaching a course on multimedia environmental impact assessment, and the goal in a course such as this, aside from teaching fundamentals of transport of elements of toxicity and risk assessment, it's to teach the students that they need to understand their role and their impact on their environment, whether they're producers or users of chemicals, processes. They need to understand it. They also need to understand in the process of what is really important, because you need to sort of figure out where is the weakest link in all of this, right? You don't want to spend, also as a researcher, you don't want to spend 10 years of your life or 20 years of your life, researching a particular area where somebody might say, exposure could never happen there, okay? Why? Because of A, B, C, D, because, the materials in the matrix that will never come apart, as an example. Then perhaps, your effort should be towards something else, how to make sure that exposure doesn't occur, right? There are different ways to sort of, open our eyes. And in the environmental area, what I always believe is that you have to be a jack of all trades, but, a master of at least one area, okay? Which basically means that you have to understand and not be biased about any particular area in the environmental sort of landscape. Why? Because ultimately the goal is for environmental, protection and sustainability. So you have to be able to see with clear eyes and without bias as to what's important. And this is what you have to instill when you're teaching, okay, as well. If you're teaching atmospheric dispersion, talk about what's most important there from the viewpoint of the impact, okay, on the real world, not just the science and the equations and the theories that you're providing. If it's in the area, and if in that particular area, for example, in this course, the students have to go through and try and figure out, what is it that can be done to reduce the impact, if there is an impact that they discover. What can be done? Is it feasible, to do that? Kind of as an exercise. And in the water area, it's for me, it's a little different, because my team of students and postdocs actually also work in the field. There are people in my group that are licensed, state of California licensed water system operators, which means that they're actually allowed to run our own systems in the field. But they go through the process and understand through those projects, what does it take to actually permit, a system? What is it that the regulators are worried and afraid of? How is it that they should convince them using their science that, our sensors are reliable? How is it that they convince them that the uncertainties are low? Every aspect of the process of what it takes to go from the science to deployment, and not to just say, well, I'm not going to worry about deployment. Somebody else is going to do it, right? Yes, it may be true eventually in reality, but as an engineer, imagine that you graduate and you have an understanding of all of that, you're able to work in any team. Whether you work on engineering principles or whether you assist people in terms of policy, you have a view of a holistic view of the system. So that's what my message would be: is that no matter what you're studying or doing research on, or teaching courses, you have to give, students and researchers have to develop a holistic, view or understanding of the environment, because one element affects another. There's no such thing as just independent elements with the environment that don't interact with anything else.
I think that's a very pragmatic perspective of looking at the systems perspective of environment, and understanding that the environment is a system of systems, and where we fit is very important for us to understand.
Right.
And it's very interesting that you have your students working on actual on-site projects. That is very important, as I also personally believe that a student of engineering especially will not learn engineering if they don't get their hands dirty. So that's why we have all these perspectives. That's very interesting. So a lot of new young students of engineering, they're probably in their high school or first years of engineering. So when they are choosing their career, and if they are trying to go into environmental aspects of chemical engineering, how would you motivate them? What would be your message to them? Are they looking forward to a job in the oil fields, or are they looking forward to a career in environmental based engineering? What do you think is important for them?
Well, I always tell students, and I actually was on a webinar actually with my alma mater, the University of Delaware, talking to graduate students about a career path. And what I tell graduate students or undergraduate students, you have to follow your passion. To me, that's important. Now, once so that's, you have to follow your passion, and I always say, and you have to make a positive difference in the world. So hopefully, I mean, if hopefully your passion is more than I just want to make money. Okay, that your passion is, I want to make the next technological advancement that will help humanity in this or that area. And I hope to instill in them, and through examples that I give them, about how science and real world work can actually fit together. And so I just want to sort of track back. When you said get their hands dirty, actually that's not the case. The working in the field and having systems in the field in the water area, it's simply that our research laboratory is in the field. That's all. It's not any different. If you work in the lab, you cannot duplicate the same conditions. So there in certain areas where you can do laboratory work and then infer with respect to what might happen in a real system. And there are cases where you just can't duplicate the same. In the case of water, you can't duplicate the same flow rates. You can't duplicate the same, water chemistry that you would see. You can't duplicate the type of temporal variability that you would see. So we have systems in the field. Actually, we have full laboratories that are field laboratories. So it's really doing research with a field scale or with a real scale, system. But not to digress and go back to your question. You have to have passion, and you have to want to make a difference in the world. I found that most of the students today, in fact, are very motivated by issues that have to do with sustainability. Whether it's water or air. So, from my perspective, I see that. I see students that want to impact human health in of course in a positive way. So they're going to the bio area. I see a lot of students that are going to the environmental area, and maybe they're not declaring it as environmental. Uh, but in my case, students that work with me on material science, but for membranes that are used, for water technology, is that environmental? Well, depends on how you treat it, right? You have a goal, to make something, to develop a material, a membrane that will allow you to purify water. And if you're successful, then you've impacted water technology. In the process, you've done fundamental work that is on material science. So you try and meet really the challenge in both worlds. And I think what faculty can do is lead by example. So I personally don't find it very difficult because I don't have to tell them stories that are derived from other resources. I just tell them what I do and what impact the work has and why and what is the driver. And I find that is the motivation when you tell them that what you do and what they can do is really have impact on society, on the world around them, in a positive way, and at the same time make a good living. I think that that's a motivation, and that's what we should do is kind of drive the passion in them, but dual passion for the science, for the engineering, but also the passion to do good.
Mm-hmm. Mm-hmm. Yeah, that's a great observation. So I think we are coming to the end of the session, and if you have any concluding thoughts and remarks, both for the environmental division as well as the environmental chemical engineering community in at large, if you have any concluding remarks.
Well, I'm just so happy that the environmental division is thriving. Uh, from the days where we were worried about who is going to help lead the division and put in the work, to seeing that there was so much interest and so many people that are, excited about it and realizing the connections that they can forge, throughout the profession, I think is a dream come true. So I'm very, very happy about it, and that the environmental division is nowadays, at least from what I see, is regarded as one of the serious divisions and the visible divisions within AIChE. I would like, I mean, in terms of, in terms of my wish, being involved with the AIChE, with their various environmental, efforts, is to see that the environmental division, becomes, more and more, entrenched in collaborative efforts with other, with our other societies, with other groups also outside of AIChE. AIChE is making this effort. Okay, AIChE is making this effort in collaborating with other societies, but I think that the environmental division can play a very, very important role there, as well. And I think that would be important so that when the community thinks about, and I'm saying the scientific, the engineering, the policy community thinks about environmental, issues, they should have in their vision AIChE Environmental Division.
That is a very good thought to have for the division. We are, I would like to let you know, and also the viewers let them know that we are doing work to connect with the different divisions within the AIChE, for example, the management division, the chemical engineering and the law forum. In fact, our service award winner this year is Mary Ellen Turns. She has been a chemical engineer and a lawyer for environmental issues. So it celebrates her career as well as her contributions to the division in terms of policy and law. We understand the importance of policy and law in environmental aspects, so we work very closely with that. We have also been working with the Fuels and Petrochemicals Division, the Computing and Systems Technology Division, and the Separations Division and the Nuclear Engineering Forum to bring in cross-programming, cross-linkages. But again, we are taking those strides. We have done some of those work, but we have a long way to go, and connecting with different other societies are also very important, as you mentioned, and we will definitely consider that for the future.
Yeah, well, yeah, I think that there's definitely, definitely room to grow, and I think that certainly strengthening the connections within AIChE and the different divisions, of course, is key. If you don't have that, then it's hard to sort of go outside.
The other thing that I would like to put forward is that we are actively recruiting volunteers for the division. So if you have a recent graduate student or students who have already graduated and are in the work area, if they want to be involved with the division, we would very much welcome that. And we have very good leadership positions. You already know that, but definitely like that would help us in growing and also bringing newer perspectives from research into the division. So with that, I would like to thank you again for your time. And this has been a really good discussion. Thank you very much. And we'll put this up on the website, and we'll let you know when this comes up online.
Okay, well, thank you. I think it was fun talking to you, and many thanks for working so hard on behalf of the environmental division, and basically continuing and carrying on with carrying the torch.
Thanks. Thank you so much.
And have a good day, or in your case, I guess it'll be close to early evening.
Yes, and of course, like during the COVID times, we have to stay safe and stay healthy.
Yes.
We are looking at a different kind of environmental problem, I guess, but it's a biological environmental problem. But we will get over it pretty soon, and we'll be back on track of doing good for the humanity.
We hope so. So have again, thanks. As you say, stay safe, and I look forward to seeing you sometime soon in person.
Absolutely. Thank you so much.
All right,
Have a
take
great
care.
day.
Bye.
Bye.